Hello dear students, welcome to ECE Academy Benefactor. In this class we will be seeing the derivation of RIF, that is the input resistance of current series feedback amplifier. This topic is from the feedback amplifier. The subject name is electronic circuit analysis, ECA. Let us start the derivation. As we have seen the block diagram of current series feedback amplifier in our previous class, let us quickly review it. So, how to decide the basic amplifier? We have taken transconductance amplifier of again GM. How to decide this? So, the first word indicates output. Okay, what is the output? I0. So, at the output what is done? Sampling. If current sampling is there, what type of connection is to be there? It has to be series sampling, series connections. Okay, if current sampling is done, the connection at the output side is to be series. And the second word tells about the input. What type of mixing is done at the input? Series mixing. If series mixing is done, what is the output parameter? What is the output parameter? What is the input parameter for this? Is a voltage source. Okay. So, if you look at this current series, let me write it here. Current series, by this name we have to decide. The first word is output. At the output side we do sampling. What type of sampling is done? It is current sampling, that is I0. Okay, if output current sampling is done, what is the connection to be done? It is series connection. Okay, so at the output side you need series connection. At the output side we do series connection. And at the input side, the second word tells about the input. What is done at the input side? Mixing. At the output side we do sampling, at the input we do mixing. If input is series mixing, what parameter is mixed? It is voltage. Okay. So, what is the input parameter? Vs or Vi. Input param to the amplifier will be Vi. Okay. So, output is I0, input is Vi. Okay. So, this is here mixing, series mixing, the voltage is mixed with Vi. Okay. So, I by V, what it is? Ohm's law you know, V is equal to IR. So, what is R equal to? V by I. What is the reciprocal of I by V? It is G, transconductance. I by V ratio is transconductance. So, this I0 by Vi is known as GM, transconductance. Okay, so we need a transconductance amplifier. A transconductance amplifier of gain GM. To this we have connected a feedback network of ratio beta. At the input side, what is series mixing? So, if the series mixing is done, we need to connect a voltage source. We have connected a voltage source. And series mixing, so it is series connection. The feedback connected to series to the input at the input side. So, this dotted box is showing that it is series mixing. At the output side, we are having current sampling. For current sampling, what connection? Series connection. So, the feedback network is connected in series at the output side. This dotted box indicates that it is current sampling. So, current sampling, series mixing, hence the name is current series. We have connected a load resistor RL. I0 is the current flowing, which is equal to IL. So, now to derive RIF, we need to know what is the equivalent circuit of this transconductance amplifier, which we have already seen in our previous class, which I have drawn it here. So this is the input side, Vs source voltage, source resistance. When the voltage is there in series, we connect a source resistor of resistance Rs. GMVI, what is Vi here? This is the input voltage plus minus. GMVI, a current source means parallel resistor, voltage means series resistor. So R0 is placed and then RL. This is a transconductance amplifier. Now we need to draw this diagram. We have to replace this block by this equivalent circuit. What is it feedback network doing? It is taking a part of output parameter and giving back to the input with the help of the feedback voltage Vf. So here at the input we see three voltages, Vs, Vi and Vf. What is Vf equal to? What is Vf doing? It is taking part of output voltage. What is the output parameter here? I0. So what is Vf? Vf is equal to beta times of I0. That is beta is what? Is a ratio. Ratio means output by input. What is the output? Vf. Input is I0. So Vf will be equal to, Vf is equal to beta times of I0. Okay, so what it has done? We have replaced this feedback network by connecting a feedback voltage at the input circuit. So without this one, this is a trans resistance amplifier which we have drawn it here. This is a trans resistance amplifier. The same diagram I have drawn it here. Vs, I have made source resistance negligible. So Rs is removed here. Ri, GMVI, R0, RL. Okay. To avoid this feedback network, we have drawn a feedback voltage. So we are having three voltages, Vs, Vi and Vf. Okay, in this way, this is a current series feedback amplifier. The name of this diagram is transconductance amplifier. This is current series. Now write KVL at the input side. Apply KVL to the input loop. You are entering to plus of Vi. Vi plus Vf. We are entering it plus of Vf and entering it minus of Vs is equal to 0. So what is Vs equal to? Vs is equal to Vi plus Vf. And what is Vf equal to? Beta times of I0. What is I0? What is I0? Now apply the KCL. This is KVL at input. Now what is KCL at output? Current entering is equal to current leaving. What is the current leaving? I0. What is the current entering? GMVI. Okay, so I0 is GMVI. And what is Vi equal to? What is voltage Vi? Is a current flowing through this resistor. So Vi is equal to I dot R, Ohm's law, V is equal to IR. So what is the current flowing? I dot Ri. So what is beta I0? Which is equal to Vi plus beta I0. I0 is equal to what? GMVI. And what is Vi equal to? Take Vi common. 1 plus beta GM. Okay. So this is Vs. And what is Vi? Vi is equal to II Ri. 1 plus beta GM. This is Vs. What is, based on this definition, what is Ri equal to? Ri is equal to Vi by II. This is the input resistance of the transconductance amplifier. What is RIF? RIF will be equal to Vs by II. Okay. So these are two different equations. This is without feedback, input resistance without feedback, and this is with feedback, input resistance with feedback. So, what is RIF now? RIF is equal to Vs by II, which is equal to Ri times of 1 plus beta Gm. Yes, the derivation is very easy. I hope you have understood the class. So, first apply KVL at the input side, KCL at the output, and then input voltage, and substitute them and find the equation of RIF, which is equal to Vs by II, which is coming to be as RIF is equal to Ri times of 1 plus beta Gm. I hope you have understood the class. If you have any queries, you can post in the comment section. Thank you. Good luck, students.